Okay, so in this lesson, we're going to be looking at exponential functions. So if you remember exponential, that means x is a part of the exponent. So there's two different types that we're going to talk about exponential growth and then decay. So if the base, which is directly in front of your exponent, is greater than 1, that is going to be a growth. So notice this base here is a 2, which means it's a growth. On the graph, from left to right, it should be increasing. That's how you know it's a growth. Then if your base is between 0 and 1, that's going to be a decay. So notice this base is a 1/2 because it's 1/2 to the x. Notice this graph is decreasing from left to right, so that would be a decay. So you can either look at your function or you can look at your graph to determine if it's a growth or a decay. So your general form of an exponential function is y equals your base to the x power, where base is always going to be greater than 0 and it cannot equal 1. If your base is greater than 1, which we already said, it's going to represent an exponential growth. And then if your base is in between 0 and 1, then it's a decay. Okay, so we're going to be looking at both of those. So we're going to match each graph to its corresponding equation, state whether each function represents a growth or a decay. Also, something else I didn't talk about, anytime when you look at your x value of 1, whatever that is, that's going to be your base. So notice this point is 1, 2, so my base should be a 2, because 2 to the first power is 2. So looking here, when x is 1, notice my y is a 1/2. So that point, whatever that is, that's your base. Because if you raise something to the first power, it's going to give you your base. Okay, so we're going to match each graph. So looking at the first one, I'm going to go ahead and look and see if it's a growth or a decay. Notice this is a growth on the graph, because it's increasing from left to right. So always read it from left to right. Notice the second one is a decay because it's decreasing from left to right. The next one would be a growth. And then the last one would be a decay. So again, by looking at the graph, you're reading it from left to right. If it's going up, it's a growth. Going down, it's a decay. So now we're going to look at our equations. So notice my base here is greater than 1. Which means it's going to be a growth. So I'm looking at these two choices here. Remember I said when x is 1, look at what your y value would be. So this would be 1, 3. This would be 1 and then a little past 1. So 1 point something. Okay, so notice my base here is 1.2, so that would represent that first graph. Notice the second one is going to be a growth. It's greater than 1. Notice it's a 3, so when x is 1, our y is 3 would be this graph here. Notice that c is in between 0 and 1, so that would be a decay. So look at your graph. When x is 1, your y would be point something. And that one is smaller, so it's looking like, if you look at your two choices, 1/4 is smaller than 0.7. So this would be C. So I'll say this is 1/4 or 0.25. And then this would be the D. So you're having to look at it. Again, a great way to look at it is when x is 1. Notice this one looks more like 0.7. So when x is 1, your y is your base. So that's a great way of determining if it's what the base is, okay? So graphically, look at if it's increasing or decreasing from left to right to figure out if it's a growth or a decay. And then from the equation, you're looking to see is the base greater than 1 or in between 0 and 1 to determine if it's a growth or a decay. So let's flip over. Now the back. We're going to be looking at Euler's number. So Euler's number is very similar to like a pi, okay? So the number pi, remember pi is 3.14. It also keeps going. It's continuous. It never stops. So these are called irrational numbers. So they're real numbers that cannot be written as a fraction because it does not terminate. It never ends. And it does not repeat. Okay, so a common example would be pi. So now we're going to look at Euler's number, which is very similar to a pi. So Euler's number is E. So it is approximately equal to 2.71828, and then it keeps going, okay? Now, there is actually an E button on your calculator that we're going to be looking at in a second. So remember from the front, our growth base is greater than 1. Our decay would be base between 0 and 1. So on your Euler's number, if there's R, so part of your exponent, if R is greater than 1, it's going to be or greater than 0, it's going to be a growth. Less than 0, which means negative, that means it's going to be a decay. So that's how you're going to determine growth or decay on those. Okay, so we're going to graph using a graphing calculator, and then we're going to represent the function in multiple ways. So I'm going to graph this. So I'm going to go to y equals, and then I'm going to type in E. So the E button, there's two of them. There's one above the division, and then there's also one above the ln. So you can use either, but since I'm having to raise it to a power, I'm going to use this one here. So I have to hit second and then ln. So I have E, and then I'm raising that to the x power. Okay, so I'm going to go to my table so I can put my points in. So second table or graph. And then we're plugging in, it says -3, so that would be 0.0498. -2 would be 0.1353. And then 0.3679. 0 would be 1. 1 would be 2.7183. And then 7.389. This one's going to go off the graph. I'll go ahead and fill it in though. Okay, you can also look at the graph. So press graph, and you can see that you have, this was going to be an exponential growth because it's increasing from left to right. Okay, so let's go ahead and plot the points. So -3.0498, 0, 1, 1, 2.7, 2 is 7, 1, 2, 3, 4, 5, 6, 7. Okay. So our domain and range, we want to find the domain and range of this exponential. I don't care how you write it. So if you look at the x-axis, notice it's continuous to the left, and then it also keeps going. So either all real numbers or -infinity to infinity. The range, however, if you look at the y-axis, is never going to include any negative y values. So you're going to be going from 0 to infinity, and it will not include 0. Notice this exponential graph here has an asymptote at the x-axis because it keeps getting closer and closer and closer, but never touching it. You could also put y is greater than 0. So either one on that. Your intercepts. So notice that this one's not going to cross the x-intercept or x-axis. You do have a y-intercept. Notice that it is crossing the y at 1. So 0, 1 would be your y-intercept. And we do have a horizontal asymptote. If you look at your graph, it's approaching the x-axis. So it would be y equals 0. Because remember, horizontal crosses the y-axis, whether it shifts up or down. And then vertical crosses the x-axis, no matter if it shifts or when it shifts left and right. Okay, this next part, we're going to use the equation to determine whether each function represents an exponential growth or decay. And then we're going to justify our answer. It says you can use a calculator if you would like to verify. Okay, so if we have Euler's number, we're going to look at our exponent, see if it's positive or negative. Since it's positive, this means that would be a growth. And I'm just going to put the r is what it calls it, so e to the rx. If r is greater than 0, we know it's a growth, because so it's positive. It would be 1/10 times x. The next one, looking at your, since it doesn't have an e in it, we're looking at just the base. Excuse me. Notice the base is greater than 1, because 5 over 2, that would be 2.5. So that means it's a growth. Looking at the next one, notice it has an e, so notice in the exponent, that is negative. So since the r is less than 0, that means it's going to be a decay. No e on part D, but we have a base. Look at the base. It is less than, or in between 0 and 1. That means there's a decay. So again, if it's just a regular exponential with no e, you're looking at the base. The base is what's directly in front of your exponent. If it's greater than 1, we know it's a growth. If it's in between 0 and 1, we know it's a decay. Okay, so pause the video, and I want you to try E through H. Pause it, and then you can come back and check your answers. So on part E, you should get growth, because the base is greater than 1. You should get decay, because notice it's negative in the exponent, so your r is less than 0. You should get growth, because your exponent is positive, so that r is greater than 0. And then the last one, you should have got decay, because notice that base is in between 0 and 1. Okay, so graphically you can determine if it's exponential growth or decay just by looking at the graph from left to right. And then the equation, you're looking at your base, but if it has an e in it, you're looking at the exponent to see if it's positive or negative. Going back, I forgot to circle up here. Notice this one was increasing from left to right, so that was an exponential growth. Okay, so now you're going to work on your assignment. You will finish it today in class. Once you're finished with it, you need to go ahead and get it turned into the box. It's pretty easy. So just refer back to your notes if you have any questions, and I will see you tomorrow.